Alright students, we are continuing our review of area, and today we're going to be talking about trapezoids and a rhombus and a kite. So let's just start with the area of a trapezoid theorem. The area of a trapezoid is half the product of the height and the sum of the lengths of the bases. Okay, so over here to the side, I want you to add height of a trapezoid, because I want to make sure that you understand that it is the perpendicular distance. It is the distance between the bases. Okay, so don't think it's one of these sides over here. It's always going to be shown with a perpendicular or right angle mark. Okay, so here's the formula. 1/2 base 1 plus base 2 times the height. Next, area of a rhombus theorem. The area of a rhombus is half the product of its diagonals. Okay, so this time you just have to find the diagonals, multiply them together, and divide by 2. So half diagonal 1 times diagonal 2. And finally, area of a kite theorem. The area of a kite is half the product of its diagonals. It has the same exact formula. Now remember, that's a typo. That should have 2, because remember, that does not equal that. Okay, so here, half diagonal 1 times diagonal 2. Notice how they don't look the same, but the formula is the same. All right, let's do a couple of examples. In the first example, it's about basketball, and so you'll see it's like a part of a basketball court, and we're talking about this area here, which is the free throw lane. The free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. In other words, find the area of the trapezoid. So remember, I always want you to start with a formula. Area is equal to base 1 plus base 2 times the height divided by 2. You can write it like that, or you can write it like 1/2, put a 1/2 here in front. Okay, so here I know that my first base up here is 3.6. My bottom base here, base 2, is 6. I know that my height, which I know this is the height because of the perpendicular mark, so that's going to be 5.8 divided by 2. And when I plug this into my calculator, I end up with 27.84 units. So look for a unit. These are going to be meters squared. All right, next. It says rhombus PQRS represents one of the inlays on a guitar. Okay, so here, if your printer's too light, this is a rhombus, so you know that these hash marks are here to show you that all the sides are congruent, and this is going to be 12 millimeters. And then this right here says 9 millimeters, and it's got an arrow pointing to this segment right here. This is QN. Okay, so first of all, I need to find my diagonals, because area of a rhombus is equal to diagonal 1 times diagonal 2 divided by 2. So diagonal 1 is easy to find. If this is 9 and this is 9, then I know that the entire diagonal, which is QS, is going to be 18. 9 plus 9 is 18 millimeters. But this one's not marked. However, I do know that the diagonals of a rhombus, they bisect each other, but they're also perpendicular. So this forms a right triangle. So I'm going to take this right triangle out right here. Draw it right here. I know that this is 12. I know this is 9, but this is what I'm looking for. So I'm going to have to use prior knowledge. Pythagorean theorem. A squared plus b squared equals c squared. Remember that c is always across from the right angle, and then it doesn't matter what the other two are. X squared plus 9 squared equals 12 squared. Okay, so I know that x squared is going to equal 144 minus 81. X squared is equal to 63, and I want to leave that as a reduced radical. When I take the square root of both sides, I want to say that that's x equals to the square root of 63. Okay, so that's just this piece right here. So if this is square root 63 and this is square root 63, I know that diagonal 2 is going to equal 2 of those. 2 times the square root of 63. Okay, so back over here, I know that my first diagonal is 18. My second diagonal is going to be 2 times the square root of 63 divided by 2. Now folks, whenever I have a radical in my formula, I want to make sure that I give the exact answer. So that means don't plug that into the calculator. You can plug this into the calculator if you want, 18 times 2. And then when you divide that by 2, look what happens. That 2 and that 2 cancel out. That's just 18. So this equals 18 rad 63. Okay, so just to recap that one. Okay, so here, if I multiply these together, I get 36 divided by 2. 36 divided by 2 is just 18. So here, 18 rad 63. So it doesn't matter if you know to cancel these out, or if you go ahead and you multiply these and divide by 2, you still get the same answer. So I need a unit, and over here it says millimeters, so that's going to be millimeters squared. And I found the area of the inlay. So I always go back and I double check my question to make sure that I've answered all the questions. Okay folks, this section you're going to be doing by yourself. Make sure that when you come to class that you have 1, 2, 3, 4, 5, these 5 answers. Make sure you show work for each one, but make sure that you have every single one of them done. And that's it for notes 11-2.